Good morning, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, a science and technology channel.
Yep, and had a little technology issue this morning, but we've got that worked out. And those are usually on my end, and we got those worked out. And today we're going to talk about Mars and a moon, one of Mars's moons.
I did not know this about Mars's moon. It's crazy.
Yeah. So,
Okay, Phobos, that's the name of the moon. Phobos' hidden interior may hold the key to how Mars gained its strange inner moon. Phobos has circled Mars for billions of years, but scientists still do not know exactly how the small inner moon came to be. One possibility is that Mars captured it as an asteroid. Another is that Phobos formed from debris blasted in space after a massive object struck the Martian surface. The answer may depend on something researchers still cannot see clearly. What lies inside Phobos? I mean, we don't even know what lies inside our moon definitively.
cheese.
No, it's meatball. Pescetti
Moon?
meatball.
Moon is made out of
Moon.
meatballs and
One meatball, one huge giant meatball.
one giant meatball. Okay.
Meatball.
That
Would
hidden
you like to
interior.
know more?
Yeah. Other than what you already just know from the last 15 seconds. That hidden interior remains a known unknown for planetary scientists. A recent presentation at the European Geosciences Union General Assembly in Vienna explored the problem by modeling tiny changes in Phobos' geophysical observables with a focus on the area around Stickney crater. Didn't make that up.
Stickney crater, which is about 9 kilometers across, could hold clues to the moon's history. If Phobos formed after a giant impact on Mars, the collision that created Stickney may have happened roughly 4.2 billion years ago. If Phobos is instead a captured asteroid, the Stickney forming impact may be much younger, closer to 2.6 billion years. Just a couple billion years off.
So that's violence going on up there, right? I mean, just impacts and collisions and
I know.
splintering off and craters and asteroids and just, man, what a mess. So, okay. In a 2026 paper in the monthly notices of the Royal Astronomical Society, published on April 21st of this year, Hosser and co-author Thomas Andert note that current estimates point to a porous interior that may contain water ice. Okay, we just talked about some water ice on the moon, right?
Yeah.
They argue that detailing mapping of Phobos' gravitational field could be critical for testing these ideas, especially if the Stickney impact created a localized region of compacted, denser material inside the moon.
The Stickney event is one of the most important events in Phobos' history, and understanding it better might help to resolve its origin. Benjamin Hazer, a doctoral student in planetary science at Germany's Universität der Bundeswehr München, told me in Vienna, told the guy writing the article in Vienna.
Okay. Phobos is small and irregular, but it is not just a simple rock in the orbit. Okay, so when they say irregular, when you look at our moon, it looks pretty much like a sphere, right? It's round, like a ball.
Yep.
So this one obviously is not that.
It's got a dent in it. Phobos has got a dent in it, so that's why it's irregular, not spherical.
Okay, and that's according to Hasser. Even so, with a mean diameter of only 22.2 kilometers.
That's small.
Yeah, and a Mars orbital period of only 7 hours and 39 minutes. That's pretty quick, right?
Yeah.
Phobos is tiny. Two theories of Phobos' origin have emerged.
The first theory suggests a giant impact onto Mars caused the fragments to bounce back into orbit, creating a debris disk, which finally results in the two moons Deimos and Phobos. Hazer and Andert write in their MNRAS paper. In contrast, spectroscopic properties and asteroid capture models suggest that both moons originated from asteroids and were captured by Mars' gravity field, the authors write.
Determining and understanding Phobos' gravitational field is a fundamental step towards constraining its interior and, consequently, its origin. Hosser noted that his EGU 26 paper, or he noted that in that paper, current estimates suggest a porous interior with possible water ice content and a denser mass concentration in its equatorial region, he noted. It's like a giant geode.
A giant geode. You would assume that such an impact would have shattered Phobos, unless it has a very low homogeneous density, like a sponge, that can absorb that kind of impact, SpongeBob, says Hazer. And at that impact region, there must be a very high temperature that melted and compressed the stone beneath it, he says.
Hosser says Phobos aligns well with the captured asteroid scenario. Its irregular shape looks very much like a rubble pile asteroid, he said. But Hosser notes that it's difficult to connect Phobos' present-day gravity field, shape, density, and spectral characteristics, and orbital evolution into one consistent geophysical picture. At the same time, its shape and proximity to Mars make the interpretation of its gravity field and internal structure quite challenging, he says. So maybe this was a chunk of Mars that just broke off, you think?
No, Scott, I know exactly what it is. Okay.
Oh, okay.
This is an alien ship in orbit studying Mars that has a cloaking device that makes it look like a moon. 22 kilometers in diameter. Come on.
Gotcha.
Right?
Okay.
Am I right?
We've got it all figured out, folks. You heard it here.
In the paper, the authors investigate how a compressed mass beneath Stickney crater affects the tiny moon's gravitational signal, moments of inertia, and libration amplitude is essentially how Phobos wobbles and oscillates, says Hosser.
Phobos' orbit is dynamically very special. It is very close to Mars, slowly spiraling inward, and will eventually be disrupted or impact Mars, says Hosser.
I did not know this. It's pretty cool.
This means that Phobos is not only a record of the past, but also actively evolving geophysical system, he says.
Now, think about this. Why would you want to put a domed structure on Mars when you know this moon is eventually going to impact? Now, even if it doesn't impact the dome, I mean, the explosion is going to create all this dust, and you won't be able to take off into space. And why would you do that?
Well, one of the first things that they're going to need to do is they're going to need to blow that sucker up so it doesn't. Take care of that.
Yeah. Target practice.
Yeah. Drop.
For the Mars Congressional Republican Navy.
Yeah. What was that thing that was in Star Wars? The Death Star? Didn't it have some kind of beam or something like that it could shoot at stuff?
That shoot at stuff, yep.
Blow it all up, and then you're good. Let it all land wherever it goes, or go out into the atmosphere or into space and go attack something else.
Settles, there you go.
Yeah.
All right, the upcoming Japanese Martian Moons Exploration, MMX, Phobos Sample Return Mission, targeted to launch in late 2026, and we'll keep an eye on that for you, will attempt a quasi-stable orbit about the tiny moon. This is a difficult task because, as Hazer points out, there truly is no stable orbit around Phobos.
Phobos' gravity field is strongly overshadowed by the Mars gravity field, says Hosser. Even so, the MMX's main spacecraft will use two sampling mechanisms to collect material from Phobos' surface. One core sampler will collect matter down to 2 centimeters, while a pneumatic sampler, being contributed by NASA, will use pressurized gas to loft material into a sample container, and that's according to the Japanese Space Agency, or JAXA. All samples will be subsequently sent back to Earth by mid-2031. So that's what, 5 years from now. So that's kind of cool. Via a sample return capsule constructed to withstand re-entry into our atmosphere. Kind of like, you remember, have you ever gone to Costco when they had to do deposits and they stuck that money in that tube and it sucked up? Then there you go. Yep, there goes your money.
The main puzzle, says Hazer, is not just what is Phobos made of, but what kind of interior structure can explain all its characteristics simultaneously. Understanding this is essential to distinguish between formation scenarios such as capture, formation from impact-generated debris, or a more complex mixed origin, he says. Fascinating.
Yeah,
Why
I
not
guess so.
study that moon?
Yeah, either that or they're just going to have to take care of it. They're going to have to blow it up because, like you said, it's a problem. If you're going to build some multi-billion, probably by the time they do this, multi-billion-dollar dome city or space hut or whatever you want to call it on Mars, you don't want it crushed by a Phobos.
How about this? What if you put like a planetary defense launch system on it so it could defend the planet, and then when it's coming down to impact, then you blow it up? Get some use out of it.
Okay. Yeah, and then you might be able to get some of that water ice or ice water.
You heard it first right here.
Okay.
Backyard Musings.
Yeah. All right, folks. Thanks for listening.
We'll see you.
Take care.